Welcome to This Explainer. I'm absolutely thrilled to have you here today. If you're the kind of person who just loves peeking behind the curtain to understand how our world really works, well, you are in exactly the right place. Today, we're going to decode the invisible, completely silent machinery that operates all around us all the time. We're talking about artificial intelligence. But look, not the dramatic sci-fi movie kind. We are focusing on the everyday AI that is quietly shaping your choices, predicting your needs, and navigating your world right now. We're going to break down exactly how it works so you can actually see the architecture of these systems for yourself.
Okay, let's dive into this. I want you to think about the absolute last time you went to the grocery store or maybe did some online shopping. Did you use a credit card? An ATM card? What about one of those loyalty store cards? Well, if the answer is yes, then congratulations. You haven't just been a shopper. You have very likely been an active data input for an AI algorithm. Seriously. Every single time you swipe that card, a brand new digital record of your behavior is born, and it enters this massive ecosystem that you might not even realize exists. So let's look at how that single, simple swipe turns into a massive consumer marketing pipeline. First off, your purchase is recorded digitally. Next, giant analytics companies, think places like Nielsen, gather this colossal mountain of weekly transaction data. But here's the thing, human beings literally cannot read all that. It's too much. That is exactly where step 3 kicks in, data mining. Imagine a human trying to find one matching pair of socks buried in a pile of, say, 10 million laundry baskets. It would be totally impossible, right? But an algorithm, it acts like a super detective. It instantly scans millions of weekly receipts to find these hidden threads that connect us all. It notices that, hey, people who buy brand-name diapers on Thursdays also tend to buy a specific brand of coffee. Or maybe buying a certain type of running shoe means you're almost definitely going to want a specific protein powder next month. Finally, this unbelievable pattern recognition lets these systems identify highly specific customer segments for some incredibly targeted marketing.
And the direct result of all that data mining? It's that recommended for you section you see popping up every single time you shop online. When the algorithm correctly connects the dots of your past patterns and identifies exactly which segment you belong to, it can confidently throw these specific recommendations your way. This isn't just random guessing, folks. It's a highly calculated prediction of what you are most likely to buy next. And it's based entirely on the mathematical patterns of thousands of other people who shop exactly like you do, all identified by that super detective algorithm we just talked about.
Moving right along to Section 1, Sci-Fi versus Reality. What is AI really? Now this brings up a pretty fascinating question. If an algorithm can predict your grocery list or your next camera lens purchase with such eerie accuracy, does that mean the computer is actually, thinking about you? Does it care about you the way a human would? Let's separate the Hollywood fiction from the scientific reality.
To really grasp what AI is, we kind of have to rewind back to 1950 and look at a brilliant mathematician named Alan Turing. He proposed a completely new way to measure machine intelligence based entirely on behavior, specifically acting humanly. Turing argued that if a machine could communicate using natural language processing, tap into stored knowledge, and use automated reasoning well enough to actually trick us, well then it could essentially be considered intelligent.
Now what's really interesting about this slide is how simple yet absolutely profound this setup is. Turing's idea involves a human interrogator sitting on one side of a wall, communicating blindly with two unseen subjects on the other side. One's a human, the other is an AI system. The computer passes the test if the human interrogator simply cannot tell which written response came from the machine and which came from the person. See, it's not about the machine actually feeling anything at all. It's entirely about simulating human behavior so convincingly that the illusion is just completely perfect.
And right here is where we really need to bust some major Hollywood myths. When movies show us robots with deep feelings, existential dread, and true self-awareness, they are depicting what we call strong AI or hard AI, a truly conscious mind. But listen, that is purely hypothetical. It literally does not exist today. Our current reality is weak AI or soft AI. Siri, Alexa, self-driving cars, and yep, those super detective shopping algorithms we just broke down, they are all weak AI. They're basically incredibly effective tools designed to solve specific, well-defined mathematical problems, but they possess absolutely zero genuine understanding or consciousness.
All right, let's jump to Section 2, Under the Hood, Anatomy of an AI Agent. So if the AI interacting with us every single day isn't a conscious mind, then what on earth is it? How do these real-world, weak AI tools actually function in their environments? Let's lift the hood and look at the basic anatomy of what computer scientists actually call an intelligent agent.
Just like us biological creatures, AI agents need a way to interact with the world around them. An agent uses sensors to perceive its environment. Think of this as the AI's version of human eyes or ears. It could be a camera lens, a microphone, or even just a line of code reading your credit card swipe. That perception feeds directly into a decision-making mechanism, essentially a processor running condition-action rules. Finally, the agent uses actuators to take action in the environment. These are basically the AI's limbs. So for a physical robot, it might be a mechanical arm or a steering wheel. But for an online algorithm, it's the specific text or image that suddenly pops up on your screen.
And this brilliantly illustrates the concept in action. Forget about complex self-driving cars for just a second. Picture a super simple, robotic vacuum cleaner agent. It operates in a tiny two-square world, square A and square B. Its sensors can only detect two pieces of information: its current location, and whether that specific square is dirty or clean. And its actuators? They can only perform a very limited set of actions. It can move left, move right, or suck up dirt.
So the crucial point is in this condition-action logic right here. This table is exactly how the vacuum thinks. It doesn't contemplate the philosophy of cleanliness or worry about the existential dread of dust bunnies under the couch. It just follows rigorous mathematical rules. If it perceives it as in square A and square A is clean, it moves right. If it perceives square A as dirty, it sucks. That's it. It maps a sensory input, what we call a percept, directly to an action. This is the absolute bare-bones foundation of a simple reflex agent achieving its goal without a single shred of actual consciousness.
Which brings us to Section 3, the environments of AI. Now, sweeping a tiny, completely empty two-square room is incredibly easy. But as we all know, the real world is messy, it's chaotic, and it's completely unpredictable. Let's look at how the difficulty of building an AI agent absolutely skyrockets depending on the environment it has to operate in. First off, we have to consider if an environment is static or dynamic. A static environment, like that perfectly empty house for our little vacuum cleaner, sits completely idle. The surroundings do not change while the agent is taking its sweet time deciding what to do. But a dynamic environment? That is constantly shifting. Imagine an AI trying to navigate a roller coaster ride while it's in motion. The world keeps changing every single millisecond. The agent has to perceive, decide, and act incredibly fast just to keep up with the physical reality whipping around it.
Let's move on and see how this builds into an even more complex challenge. Deterministic versus stochastic environments. In a deterministic world, think of a game of chess. The next state of the board is completely determined by the current state and your specific move. There are absolutely no random surprises. But a stochastic environment? Oh, that is highly random and unpredictable. You cannot completely determine what will happen next, literally no matter how much data you have.
And that brings us to the ultimate real-world test, an automated driving system. A self-driving car agent operates in an environment that is intensely dynamic and highly stochastic. The AI is constantly taking in percepts through video, sonar, and GPS, all while trying to juggle conflicting goals like safety, speed, and actually obeying the law. It has to act by steering and braking in a world full of unpredictable pedestrians, suddenly changing weather, and totally erratic human drivers. It is a brilliant, high-stakes example of a multi-agent, partially observable environment where the AI simply must adapt instantly.
As we wrap up this explainer, I want you to realize that every single day, you are stepping into the environments of these intelligent agents. When you swipe a store card, ask a voice assistant for the weather, follow a GPS route, check your retirement fund, or even just browse personalized movie recommendations, you are leaving a digital footprint. You are interacting with incredibly powerful, goal-directed, weak AI systems designed solely to map percepts to actions. So, I want to leave you with this one thought to carry into the rest of your day. Knowing what you do now about sensors, algorithms, and environments, how many unseen AI agents have you already interacted with today? And maybe more importantly, what specific goals are they trying to maximize by interacting with you? Think about it. Thanks for joining me on this explainer, and keep learning.